Hey everybody, today we are going to solve another daily LeetCode challenge, problem number 1302, deepest level sum. So given the root of a binary tree, return the sum of the values in the deepest level. So in this tree that given here, what we are asked to do is to, first of all, we should find the depths of each level. So here we have level 0, level 1, level 2, and level 3. So these two nodes, nodes 7 and nodes 8, are at the deepest level. So the problem is to ask first, after finding those deepest nodes, return the sum of the values of that deepest level. So in this case, it would be 15. So again, what we are going to do is using a basic tree traversal, and then by traversing, we should know the level of each node. So starting from level 0, and then while we are traversing a tree, when we are going to the next level, we are just keep track of this value. And then I'm going to use a dictionary hash map to keep track of the sum of each level separately. And after, at the end, we are just returning the sum value for the deepest level here. So to do that, one way is to use a dictionary, but I would, as always, I would rather to import default dicts. Collections, import default dict. So, and then while we are initializing this class, default int. So this is a dictionary I'm going to use to keep track of the sums for each level separately. And the benefit of using default dict here is when we are passing the type. So by default, if the key does not exist, initially it will be 0, and then after that, so we have the value. So, and then we need to implement our traverse function. Traverse self. So for traverse, we should have the root and then the level, which initially is 0 when we are starting from the root here. So yes, and then what we are going to use, first call the traverse function on the root, and then return self.sums. This is the dictionary that we have the sum already. And then for the key, so we know that starting from here, all of these nodes are level 0, level 1, level 2. So we should have find the maximum in the keys first, and then return the value of the sum of those levels. So it will be the maximum of self.sums.keys. So basically keys here is a level. So first we find the maximum. The other way could be while we are traversing a tree, just keep track of the maximum value somewhere like here, self.max level, and then after that simply use that. But since a given n nodes, after that computing this itself, it should take O log n if we assume that the tree is already balanced, and then so this is the order of the height of the tree. If it is balanced, it would be O log n. And then traversing the tree itself, it is O of n of since we are visiting each node only once, so it would be O n runtime. And here we are also having a O of the height of the tree, or O log n in a balanced tree of space allocation, because we have for each level we are keep tracking of the sum of the values of that height. Okay, so in order to break our recursive traverse function, if the root is none, just return none. And then we are adding that sums of level. We are adding the root.value. So here, this is our tree node, and then we are just adding the value to the sum. And then calling the traverse function recursively on the children of the root. Left with the level +1, the same for the right node. And that's it. So let's see. Okay, let me submit that. There we go. So this is the way. So the other way, as we discussed, we can keep track of the maximum value here instead of running that. So let's do that. So self.max level equals 0. And then here, we just use that to know what is the maximum level. And then each time when we are visiting a node, simply self.max level equals maximum of self.max level and the level of the node that we are visiting. So let me test that first. Okay. Okay, so that's it. So sometimes the runtime doesn't improve, but because the script is running in Python, but in the compilable programming languages like C++, C#, the runtime could be improved. But in this case, there's a randomness in the runtime, but if we submit that again, it might be improved, but just a little bit. So these are two ways to access the maximum level, but today's problem was a classic one for traversing a tree. So again, don't forget to, after submitting your solution, just see the discussions and compare your runtime and space allocation with other solutions to learn from them.